All right, in this video we are going to talk a little bit about why the Earth is heated unevenly by the sun. There are three factors involved with that. But prior to that, I want to just give you the atmospheric characteristics in terms of the actual layers of the atmosphere. So this is our outline. We're talking about global processes that basically determine weather and climate for our planet, the uneven heating of the Earth, atmospheric convection currents, relation of the Earth, rotation of the Earth on its axis, the Earth's orbit around the sun on a tilted axis, and also the ocean currents. All these have a significant impact on weather and climate. Weather, again, being short-term, climate being on a long-term. Now, let's go ahead and talk about some of the atmospheric just the atmospheric layers, if you will. And here's what's most important to remember about those. There are 5 layers. The atmosphere as starting from the Earth and moving on out. Okay, so the one closest to the Earth is called the troposphere. All right, and this is sometimes called the weather layer because this is where the weather takes place. All right, this will typically go, it is closest to the Earth. Make a note of that. All right, it will typically go to, it extends to about 16 kilometers, which is around 10 miles above the Earth. 10 miles up. All right, the weather does occur here as mentioned. There is lots of air circulation in this particular layer. All right, and there is mixing of liquids and gases. Get mixed pretty extensively. All right. The other key characteristic here is the relationship between altitude and temperature. All right, I'm going to show this down here like this, just on a quick XY for you. All right, and it will look kind of something like this. It may be a little more curved, but that's the general idea. And this is an inverse relationship. All right, so as I go higher, you've experienced this in the mountains, I'm sure. As you go up in the mountains, it gets colder. Okay, that's an important characteristic to remember in the troposphere. All right, the next layer. All right, I'm going to move my down here. The next one is called the stratosphere. All right, and the stratosphere is right above the troposphere. This is the next layer up, we'll just say. All right, and the stratosphere goes from roughly 16 to 50 kilometers. All right, above. All right, above the weather layer, I should say. One thing that's very significant here is that this contains the ozone layer. The stratosphere contains the ozone layer. All right, which protects us, okay, against the ultraviolet rays of the sun. We can have DNA damage. And cancer in organisms. All right, caused by this. So a protective layer is this ozone layer. This is contrasted. We'll be talking about in our pollution unit the ozone that is actually in the troposphere, which is generated. Okay, that's a little bit different. That's a key component of smog. This one here has a relationship that's a little bit different in terms of air temperature and altitude. This is a direct relationship, just the opposite of what happens in the troposphere above. All right, and so those are some of the key characteristics to remember from that. All right, the next layer up is I can put it here, I think. The next layer up on top of the stratosphere is called the mesosphere. All right, and I think the couple of key things to remember, this is probably, I believe, around 50 to 100 kilometers up, okay, above the Earth. And the relationship temp-wise with altitude getting my XY graph here, air temp. Okay, this relationship is also a inverse relationship. All right, very similar to what we saw up here in the troposphere. So as you go up in altitude in the mesosphere, it actually gets the temperature will drop. And I think those are the most important things to remember about that. The last two levels, the next level is called the thermosphere. Okay, and that will typically go, that is above the mesosphere. Altitude-wise, approximately 100 to 600 kilometers up. And this is where a lot of the lights are seen in the North Pole and the South Pole. This is caused by some charged gas particles, basically, that glow and produce light when they're combined with with solar energy. I'll just put here North Pole. Note these are noted around the poles because of the interactions of the gas particles and with solar energy are driven by magnetic forces at the North Pole and the South Pole. So North Pole, these glowing gases are basically called aurora. Or northern lights. And above the at the South Pole, these glowing gases are called aurora australis. Or the southern lights. All right, and the last significant layer, if you will, of our atmosphere, I don't know if we need to know a whole lot about it, I'll just identify it for you, is the exosphere. All right, that would be above, way up. That would be above the thermosphere. All right, and that's typically greater than 600 kilometers up. So way up there. All right. And so those are the 5 layers of the atmosphere, and on the neck, and so wanted you to know about those. Thank you very much.